The journey continues now in 5B as we add yet another, couple of entities and a new relationship to our medical office as well. It is, as shown on the screen here, a many-to-many is what we're going to be doing, right? So just a quick review here. We'd had this discussion before, but when we have a many-to-many, there are two basic flavors. The type with no payload, in other words, there's nothing to be stored in the intersection or associative table other than what's there at the minimum to support the many-to-many relationship between the two other entities involved in the family, right? So in this case, a student is enrolled in many courses. A course will have many students enrolled, right? By the way, that term enrollment then, that's an obvious name for the associative or intersection table or entity itself, right? Just a reminder, we mentioned before that there isn't always an obvious name for the role that this intersection table plays. So, what we'll do in a case like that is usually just concatenate the names together. So I could have called it student course, right? But enrollment, it's a very clear and understandable name for its role inside the overall model here, right? So a couple details. Remember, both of the parents then in this family, the student and course, contain I collections of the child entity, right? The common child, the enrollment entity. The only properties in the enrollment are the foreign keys, right? We've covered this before. Basically, the foreign key is made up of a nullable object of the parent type. And for our convenience, so we can access it as programmers, we always throw in the corresponding foreign key of the same data type as the primary key. And so since our student and course both have integer identity primary keys, we have two integers here for student ID and course ID. And notice they're both required in this case, right? They are absolutely required, so we cannot have an enrollment without specifying both the student and the course. Okay, quick reminder here then. So what we end up doing in the associative or intersection table is we create a composite key for the primary key, a combination of the two foreign key integers, right? And that gives us our primary key. Normally, if you ever needed to access this entity directly, it's easier if it has its own separate primary key, but that's not the case. We never actually directly even create a controller for the intersection table, right? It's managed from the parent entities. So here's where we talked about using checkboxes or things like that to handle that situation. Again, this is the no payload one. So we will need a DB set for the intersection table, right? And then in on-model creating in the Fluent API, we will add the composite primary key, okay? So it'll be .has key, and with our lambda expression for the new combination of the two foreign keys. And just a reminder then, we often use checkboxes, list boxes or something, because there's no other information to store there, right? So that's all there is to it. Okay, so getting back to Visual Studio then, or actually maybe just for a moment, I'll highlight exactly what it is we're doing here. So if you recall our data model for our medical office, right? So what we're going to do is add the medical history, right? So here, the relationship between patient and condition is exactly as we were just describing. So our patient condition, okay, entity here, right? Notice the two foreign keys coming into it from patient and condition. We have the little line showing there that the foreign key is part of the primary key. In fact, that is the primary key of patient condition, will be the combination of the two foreign keys. Good, so that's exactly what we're about to set off to do, right? So here I am back in the medical office, exactly as we left it off at the end of our last endeavor together with 5A. So now, what medical conditions have you had in the past? So picture going to the doctor's office for the first time, you're given a form and you check off, yes, I've had measles, check, I've had mumps, check, et cetera, right? Okay, so we're going to have to start off by adding some new models. So let's go to the models folder. I'm going to right click and we're going to add a class here. I'll call this class condition, short for the medical condition. And it will have some simple properties here. Of course, we need a integer identity primary key. We said that would be our standard approach. Then we have the name of the condition, okay, condition name, display, medical condition, required, you cannot leave it blank. And if it's more than 50 characters, we're going to say it's too big, right? Now, it will also contain that child collection of patient condition objects, which I haven't made it yet. So it's saying, hey, wait a second. But I'm going to have a display name here simply called history, short for the medical history itself. Okay, let's get the next one in place. We'll add another class. This one indeed is called patient condition. I couldn't think of a more meaningful name, so I'll just go with that. We never really see it in particular up on the screen, so it doesn't make that much difference in this case as well. Okay, so we have, of course, nullable objects, the patient, the one parent, the other parent, the condition, right? And along with that, the two integer foreign keys to correspond to the IDs of patient and condition, right? Good, okay. Now, one thing we're missing is back in the patient class, we need to add our same I collection, right? So I'm going to come down here where all the keys sit at the end, okay? I'm going to throw it maybe after primary key, and here's our patient condition collection. Okay, now that's good for the models, but now we have to get things set up inside the actual DB context. So let's come to the medical office context. We need yet another DB set, but actually two, okay? One for the actual condition and one for the associative entity, okay, our patient conditions, right? Okay. And then down in the Fluent API, as was mentioned, we need the many-to-many for the primary key for the many-to-many intersection table. So we'll add that. So our model builder of the entity patient condition has key, okay, the combination of the two, condition ID and patient ID. All right, one last thing to do in here, think about cascade delete. Whenever you have relationships, we have to think about that. So what do we want to do here? Well, basically, we want to prevent deleting a condition that is in the history of any of the patients, right? Now, when we delete a patient, mind you, it makes sense that we would want to allow cascade delete to why, if the patient's no longer going to be in the system, why try to have a record of the medical history of the patient? That doesn't make sense. So just one side of this family relationship situation is going to be restricted. And that is this side here, okay? I could write it again from either point of view, but from patient condition has one condition. With many patient conditions, the foreign key condition ID, behavior, restrict, right? So on delete, if there are any patient condition or medical history records, okay, of a given condition, then no, we cannot remove that condition from the database. We don't have to specifically allow, okay, the cascade delete from patient to patient condition, because that is, without it being a nullable foreign key, that is automatically in place. Good. Okay. All right. So that's basically everything. We're ready to actually modify the database now. Not too bad, eh? Okay. So coming down to the package manager console, let me get my common commands open. So we're going to add a migration to the medical office context. I'm going to call it medical history. Okay, we built okay. That's a good thing. All right. All right, so it's good. So we're creating the table conditions, creating the table patient conditions. Notice it just has the two integers in it. Okay, so the primary key is the composite of the two, is shown here, right? The foreign key, two foreign keys. Notice we have cascade from patient, but we have restrict from condition. Exactly what we wanted. Okay, and of course, here's also a secondary index being created as well. Okay. All right, that's good. So let's come back up here. We want to update the database now. Now, I could actually leave that, right, to our initializer, our database initializer, but, you know, it doesn't hurt to do it now. That way I can watch and see if I get any red or yellow on the screen warning me that maybe it's best to actually start over. But we seem okay. Okay, so that's good. So we actually have that ready. Now, I'm going to, before I forget, let's come down to program.cs. Think about our initializer then. Do I want to delete the database? Well, you know, I guess it's not going to hurt at this stage. I don't have any data in there that's precious to me at the moment. So I'm going to leave all these options as true for now. But it's always good to think about that. Okay. Before we actually run it, though, do we want some seed data? Well, of course we do. Of course. So let's come to the initializer again. Let's get the medical office initializer open. And of course, we have our nice regions and everything now. But so I don't need to do anything in my prepare the database region. Okay. Thinking about seeding data, you always have to stop and say, okay, the order matters, right? Obviously, okay, I have to have conditions in place, okay, and I'd have to have patients in place before I could ever add any records into the intersection table, the patient condition, right? So where should each of those go? Well, the conditions, my medical history choices, okay, measles, mumps, etc. Well, that's pretty much required data. So that should be the region that I want to add that. So let me come here to seed required data. And it can come after medical trials. There's no relationship between those two. So I'm going to just put it right here then, inside the same try block. Okay. There's the, first of all, the one for medical trials. Okay. Then I'll add conditions here needed for production and during development. So if there aren't any conditions, then I'm going to add my list. So again, I'm using a array of strings. It's nice and easy that way. I'm just going to put some enters here so you can see it on the screen more easily. So I just have a bunch of things. You can play around with this list if you want. Just a for each loop, okay, for each of the conditions. I'll just generate a new condition object where the condition name comes from my array, basically, and call save changes. If it's empty, there'll be no problem. I don't have to worry about anything fancy other than that. Okay, so that fits nicely inside this region, right, for the actual required data. Now, I might as well throw in a little bit of sample data, right? Again, to add some patient conditions. So this needs to come after, right? Has to come after patients exist, or I can't possibly do it, right? Okay, now we already have conditions. So I could come down right here, right after I've manually added my few patients, okay? I could put it right in this same try-catch block. Let me get my code. I'm just going to manually pick a few of my patients that I know exist by now and basically give them some medical history. Okay. Seed a few patient conditions. We already have a few conditions and some patients. Okay. Just be careful you choose patients that exist. But I was pretty careful of that. So I've got Fred Flintstone and Wilma Flintstone, giving them a few of my conditions here that I know I've added higher up, right? Okay. So that should be all right. We should be good there. And that's good. Okay. Now to see the medical history on the patient index and details views, we're going to have to do some work there. So let me close the initializer. We're done with the initializer, at least for now. So coming down to views for the patient, for the index, details, and delete views. I want to show something about the medical history here, right? So I'll start with the index. We took out a couple of columns there. We took out the phone number and the email earlier. So I think I can try to add a new column here for medical history, right? Maybe in front of coverage. Okay, I'll add a column here. Display name for patient conditions, right? Okay, and then coming down into the for each loop, again on top of or before the coverage column, I'm going to add a table data pair. But this time, I'm going to use a for each loop to go through all the patient conditions showing the condition name, right? Just with a BR tag. So they're just listed one above the other, right? Good enough for now. We can worry about improving that later on if we find we need to. But at least that gets it up on the screen. So that's good for the index. Now for both details and delete, okay, maybe again, I'll put it right above coverage after the email. And it's going to look exactly the same on both, using the same structure for displaying data here, right? So a display name for patient conditions, and I'm just going to do the same thing. List each one with a BR tag, so they're one above each other, right on the screen. So I can do that in details. I can do that in delete. All right, so after the email and before coverage. Okay, so that's all good. All right. Now, one thing we haven't done yet is haven't made sure that the patient conditions are there, right? And of course, along with them, see, we need to go into the patient condition, go to the condition object to grab the actual name of the condition to show it. So there's going to be a couple things we need to include, keyword there, include, as we pull data to present on each of these views. So let's come up to the controllers, to our patient controller, right? Okay, so here's my index action. So right now I have patients, including the doctor, including the medical trial. It's just like, if you don't have any idea how nasty writing the joins would be for this if we didn't have the dot include. Yeah, really bad. Now just wait another moment and you'll see it would get even 10 times worse, right? Here is how it works across a many-to-many like this. From the patient, okay, remember it goes from patient down into patient condition and then back up again and over to condition. So from patient, we include the patient conditions, right? Those records in the medical history that the patient has. Then, see, dot, then include, and we go on to the condition, right? So these chain together basically that way. And now we're going to be joining all this information together in an SQL query, but the bottom line is every patient object will include all of this additional information. It will have the patient condition objects collection, and each one of them will even have the condition object contained inside it, fully formed with all the data coming from the database. Okay, so we have our ISO tracking. So down here, basically the exact same thing. Add the include, then include, right? And then as we come down to the deletes, the pair of deletes, we'll include them all here so that it can be up on the page. We can actually see that medical history information as we decide whether or not we're going to delete. And because we're going to be redisplaying, we want it here as well. Okay. All right, I'm feeling brave, so let's try running it and we'll see what it looks like on the screen so far. It should have applied our migrations. Seeded our data. Oh, sorry, it opened on my other screen. I didn't even see. So here we are, patients. So look at that. So Fred Flintstone, we see cancer, cardiac disease. Wilma has diabetes in her history. And we see that as well here on the details page. If I went to delete, okay, all the information is there about the medical history as well. Very good. Okay. All right. Now, the biggest job we have to deal with now is actually maintaining this information, right? That needs to happen both on create and on edit. Okay. Whew. Maybe I should stop and start the recording.